Now that we know how to simplify rational expressions, I have 3 examples of how to do so. Let's start off with, and I intentionally made these kind of difficult examples because that way we'll have a pretty good idea of what to do. Okay, so for this first one we have 4x squared plus 14x plus 12 over 2x cubed minus 5x squared minus 12x. 4x squared plus 14x plus 12 over 2x cubed minus 5x squared minus 12x. Okay, so the very first thing we want to do is factor the top and the bottom completely. So this requires that you understand how to do Chapter 6. So how would we factor out this first term? First we think, are there any common factors? There are, because each one of these is an even number. We have 4, 14, and a 12. So that's going to be, we're going to be able to factor out a 2. So we'll end up with 2x squared plus 7x plus 6. So all I did here was I factored out a 2, and on the bottom here, are there any common factors? There is one. There's x. We have an x cubed, x squared, and x. So there's an x common to every term. So this is going to be, we can pull out the x and we'll have 2x squared minus 5x minus 12. So 2x squared minus 5x minus 12. Okay. So now we think, is there any way that we can factor these individual parts? Let's take a look at this first one. It's not a difference of 2 squares. Basically the only thing we can do for this one is factor out by guessing and checking. And that's fine, that's what we do. So if we have two things that multiply, two binomials that multiply to make this. So we'll have 2x. We're pretty sure, we know that the first one for each of these is going to be, one of them is going to be 2x, the other one's going to be x. We also know that there's a plus here, so they're both the same. They're either both plus or both minus. And there's a plus here, so they're going to both be plus. So now we need two numbers for the right sides that multiply together to make 6 and add together to make 7. Well, not add together to make 7. That add together once we multiply it all out. So we just guess and check. So what's two numbers that multiply together to make 6? Well, 2 and 3. So let's do that and guess and check and see if that works out that way. So we'll do 2x squared. So we'll have 2x squared plus 6x plus 2x plus 6. Okay, well this is going to equal 8x, and that's not what we want. So that does not work. Let's try it over here. I'll put a divider for 2x plus 3 times x plus 2. And in retrospect, this is a little bit abstract, but I can see now why that didn't work, because we had a 2x plus 2. So that means that we could pull out of that a 2x plus 2, which means that had this been the correct answer, then we could have pulled out another 2, and we can't pull out another 2. That's very abstract. You don't necessarily need to know that, but it's just if you notice I hesitated because when I noticed, oh, there's a reason that won't work. So that's why, at any rate, there's a reason why this one didn't work. So let's try this one. I know this one's going to be the one that works. So we have 2x squared, because 2x times x plus 2x times 2 is going to give us 4x plus 3x plus 6. So this is the right one. 2x plus 3 times x plus 2. So I'll go ahead and it looks like I'll have enough room for that. So on the next one over, I'll write that as 2 times 2x plus 3 times x plus 2. So for the numerator, I just separated this, I just factored this out into 2 times 2x plus 3 times x plus 2. Okay, now I'm going to clear all that off, make doubly sure that the screencast program understands that I want that cleared off because I don't want to write over what I just wrote over. Okay, so now we have this 2x squared minus 5x minus 12. So we'll guess and check to figure out how to factor that out. So we have 2x, two numbers that multiply together to make 2x squared is going to be 2x and x, and two numbers that multiply together to make 12. One's going to have to be plus and the other one's going to have to be minus. So it's going to be 3 and 4. So 2x squared is for the first one, minus 6x, because 2x times negative 3, plus 4x, and then minus 12. And this doesn't work because we have negative 2x, we want minus 5x. So that doesn't work. Put a divider here, and let's try 2x plus 3 times x minus 4. So 2x squared, because the 2x times x, 2x times minus 4 will give us minus 8x. And then plus 3x minus 12. And this minus 8x plus 3x, that's going to give us minus 5x. So I'll go ahead and finish this up just for the heck of it. So minus 5x minus 12. So 2x squared minus 5x minus 12. And let's go ahead and that means that this is the correct factorization of this right here. So let's go ahead and try that out. So not try it out, I mean let's go ahead and write that out. So we have 2x plus 3 times x minus 4. So let's go ahead and clear off everything I wrote there. So now we see something that can be canceled out. We have this 2x plus 3 on the top and this 2x plus 3 on the bottom. Now if we want to, we can write this out as two different fractions. We multiply together and see that one's equal to, that one of those two fractions will be equal to 1. But we just have the basic cancellation property, so we can cancel those out. So we'll have this top one will be canceled, and with this bottom one. So 2x plus 3 is going to be canceled in each case. So I'm going to put this on the next line. This is going to be equal to 2 times x plus 2 over x times x minus 4. Now, to be completely technical, once we get it to this point, to have it the most simplified form, we still want to go ahead and multiply this out. That being said, you're not going to lose any points. Ultimately, if you don't, for this particular type of problem, it's for this specific problem, it's okay to leave it in this form without without distributing the 2 to the x plus 2 and the x to the x minus 4. If you wanted to, though, there's absolutely nothing wrong with that. 2x plus 4 over x squared minus 4x. Please do not think that you're going to be canceling these x's. It does not work. So just remember exactly what it means whenever you're canceling. So let's go on to another example. And here, I'll just we'll do 4a squared b times a minus 4b. Okay, so this is example 2. 4a squared b times a minus 4b over 2ab. Wait a minute. Whoops. I'm actually giving you the answer. Huh. Let's pretend you didn't see that, because that's Yeah, pretend that's gone. So, because I accidentally jumped ahead to part of the solution. So 4a cubed b minus 16a squared b squared over 2a squared. I know that you can't see it whenever I'm doing this right now, but 2a squared b squared plus 8ab. It'll be very awkward if I just leave it silent. So, okay, this is example 2. So 4a cubed b minus 16a squared b squared over 2a squared b squared plus 8ab cubed. Please, again, I reiterate this, do not cancel this. Do not say that you can cancel this and leave the, like 12a squared b squared. That does not work that way. So I reiterate that because I see that a lot and it's very frustrating. So the very first thing we want to do is we want to factor out the greatest common denominator for both the top and the bottom. What is the greatest common denominator for the numerator? Well, it is going to have, we see that there's going to be a 4 common to both of these numbers, so the greatest common denominator is going to have a 4 in it. What else is common to both of them? There's an a squared common to both of these, because you have here 3 a's, and here you have 2 a's, so you're going to have a squared, you're going to have 2 a's at least in each of them. So you're going to have a squared on the outside of the parentheses, and you have 1 b common to each of them. So you're going to have b on the outside of the parentheses. And what's left once you're done with that? So then you have, once you take out 4a squared b from here, the only thing left for that one is an a. And then minus, there's going to be a 4 here. Once you pulled out a squared b, the only thing left is b. So it's 4a squared b times a minus 4b. Now we need to factor out the denominator, excuse me. So, what is common to both of these? Well, there's going to be a 2 common to each of these. So, there's going to be a 2 on the outside of the parentheses. And what else is going to be on the outside of the parentheses? Well, there is an a common to both of them, because there's an a squared here and an a here. You have at least 1 a in each of them, and you have at least 2 b's in each of them, so there's going to be a b squared on the outside of it. Now, I know I went through that kind of fast. If you still need to go ahead and list out the individual terms to do that, that's fine. It takes longer. Hopefully at some point you'll be able to do it fast like I did it, but it's still mathematically valid to list out the individual terms and list out the factors for each of those terms. Okay, so once you divide 2a squared b squared by 2ab squared, you're going to have left over, whoops, that's something that needs to be on the inside of the parentheses. You're going to have left over an a, and once you factor 2ab squared out of 8ab cubed, you're going to have a 4. Did I write that down right? I feel like I did. Oh yeah, I did. Okay, plus 4. What did I just do? That should not be. Okay, sorry. 4b. Just a second, sorry. 4b. Like that. Okay. We're going to have, you're going to be able to divide out, sorry, once you divide out 2ab squared from 8ab cubed, you're going to have left over 4b, because you took out one of the a's and there's only one of them. You took out 2 of the b's, so there's going to be 1 left. You took out a 2. When you divide 8 by 2, you get 4. Okay, so now we got that correct. So we want to cancel what we can. We have. Let's go ahead and rewrite this long ways. You don't need to do this every time you do this, but I'm going to write out every single individual factor as long as I such a long way as I possibly can. You don't need to do this again, but I think it might be beneficial in this particular case. So this 4 is going to be 2 2's. This a squared by definition means a times a. Then of course we still have the b and the a minus 4b. This whole thing is a factor of the entire numerator. So we can't separate this any further. So let's go ahead and do the denominator now. Separate everything out as long and drawn out as we possibly can. So we'll have 2 and a and 2 b's. And also the a plus 4b. Oh, I forgot to put a dot between those two. Okay, the reason why I wrote it out this way is that now you can see pretty easily how to cancel these. You have a 2 and a 2 as a factor to both the top and the bottom. We can cancel out one of the 2's. We have an A and an A as a common factor. We can cancel one. We have a B and a B as a common factor. We can cancel one. And can we cancel these? No, we definitely cannot cancel those because this is a minus here and this is a plus. That makes them fundamentally different numbers, fundamentally different factors, so they are not common factors. Okay, now one of the reasons why I did this was to show you what's going to be kind of a shortcut. Now I'll go ahead and on the next line write out the simplified form of this once we take out all the common factors. So we'll have 2 a minus 4b on the top and b times a plus 4b on the bottom. And this is just what's left over. We have a 2 left over, which is where we got this 2. We have an a left over, which is where we got this a, and the a minus 4b. And then down here we have a b left over, which is where we got this b, and an a plus 4b, which is where we got the a plus 4b. Now, you don't need to write this out every single time. This long ways. If that helps you, that's fine. But that might be tedious sometimes, so there's kind of a shortcut to understand. This 4, you can cancel out a 2 from both of these, because there's a 2 common to both the 4 and the 2. So we can cancel this and say this is 2, and cancel this and say this is 1. This a, you have an a squared and an a here. Well, we can cancel out this 2 and say there's going to be 1 a left, and if you cancel out 1a at the top, you have to cancel out 1a at the bottom. Same over here. Cancel out 1b here, and you'll have cancel out the only b left here. You will hopefully see more of that as we go on, so that you can not in these particular videos, but you'll see more of that in examples, so that you'll see what I mean, hopefully. In fact, I'm going to go ahead and do that in a little bit more detail right now. I will say right now that before I do this part in more detail again, this is the final answer. There is nothing left to cancel anymore after this. Okay, so now that that's out of the way, I'll go ahead and this is just something to understand about the canceling. So if we have this is actually kind of getting on to chapter 8, I think, just a little bit, but it's still good to know. If we have a to the power of 3 over a squared, what this means is a times a times a. So this is kind of an aside, but it's still good. So that means we can cancel 2 a's. And we'll have just a left. We'll have a over 1, which is a. And so the thing that makes that is important to understand about that is that you can cancel this in a different thought process. You can think of it as we have 3 a's on the top and we have 2 a's on the bottom. That means we have 2 a. That didn't look like an a at all. We have 2 a's. Well, let's just rewrite this from scratch. A squared. That doesn't look much better, does it? So we have 2 a's that are common to both. Let's make this, and so then we can. Okay, so we have 2 a's that are common to both, so that we can cancel out both of these 2's, and when we cancel this, how much do we have left over? Just 1. So we'll just have a. Let's do another one. B to the 5th over b. Okay, well we have one b that's common to both of them, so we can cross out this b. We can, and how many b's are we going to have left when we cancel those out? 4 and 4. And you can see that if we want to do it, and let's do this over here. B times B times B times B times B. You can see now why we want to use this shortcut, because it can be kind of tedious to write all that out. And then we can have cross out one b, and we'll have 4 b's left over. So it's kind of important to understand that thought process. We'll go into a lot more detail on that, and I think it's chapter 8. It might be chapter 9, but I'm pretty sure it's chapter 8, the exponent rules that we'll see much more of later on. Okay, I think that for this particular example, that's all we're going to need to do. But let's go on to one more example for simplifying rational expressions. Okay, so let's clear all of that off, and we'll do we'll have x squared minus 3x minus 10 over 25 minus x squared. I intentionally chose something that's going to be just a little bit weird. Now, it might not look too weird at first, but it will in a minute. Let's factor this top one. How do we do that? Well, that's really not that hard. It's just going to be we're going to have this x squared. This is not a perfect square, so it's going to be two numbers that when you multiply make negative 10, and when you add make negative 3. Well, that's just going to be x plus 2 times x minus 3. If you don't believe me, you can do that. Wait, no, it's not. Whoops, not 3. Sorry, I saw this 3. I'm glad I caught that. X minus 5. I'm very glad I caught that before we went on. This problem would not have made sense. So, x plus 2 times x minus 5. If you don't believe me on that, you can go back to the previous videos and figure out how to factor this. This was 6.1, I think. So, that means we can factor out this top into x plus 2 times x minus 5. And what about this bottom one here? Well, this is a difference of two squares, because 25 is a square number, and x squared is a square of x. So that means this is going to be 5 squared, this is going to be x squared. So we can rewrite that as x, so 5 plus x times, wait, I just did something, okay, times 5 minus x. 5 plus x times 5 minus x. Okay, we have nothing to cancel now, right? Or so it seems. Actually, there's something that we can do, something that is not very intuitive, something that will not come to your mind immediately, but something that allows you to cancel this, cancel something. This 5 minus x is the opposite of the x minus 5. Let's do this over here. Let's do, okay, think of this binomial, a minus b. It's not a squared minus b squared, it's just a minus b. What if we take the negative of this? Multiply this entire thing by negative 1. It's going to equal negative a plus b, and it's distributed the negative. That makes this a negative. Negative times a negative makes this positive b. Negative a plus b is the same thing as b minus a. Now that is because when you're adding two numbers, then it's the same. Let me put this intermediate step here. This is, you can write this the same thing as b plus negative a. Just because, remember, addition is commutative, you can switch the order. And this b plus negative a means, by definition, the same thing as b minus a. So, when you put this negative in front of the a minus b, that's going to switch the order. So, we can put the negative in front of this 5 minus x, or this x minus 5 if we wanted to. I'm going to do the 5 minus x, doesn't really matter. But let's go ahead and on the next line I'll do this. So, if we have x plus, x plus 2 times x minus 5 the numerator. And here's what I'm going to do on the bottom. I'm going to switch the order of this 5 minus x by pulling out a negative. So we'll say 5 plus x is still going to be in to the left, but then we're going to have minus 5 minus x on the right. See, I canceled the order. Not canceled the order. I switched the order by bringing out, in a sense, a negative. Now, I could, if I wanted to, do this again, and then I'd have two negatives that cancel out, and then we'd have 5 minus x again. Basically, I know that seems very abstract, but you can check that by distributing this negative out again. So we'll have negative times x, which will give you negative x, and negative times negative 5, which will give you plus 5. That'll give you negative x plus 5, or 5 minus x. So this negative, I'm going to do this to the right. I'm going to make this another x plus 2 times x minus 5 over 5 plus x times negative 1 times x minus 5. Now all I did here was I just decided to this means the same thing as negative 1 times x minus 5. So that's just what the negative means, more or less. So I just did that so that I can see it more easily where I can cancel. So now we have something that we can cancel. X minus 5 on the bottom and x minus 5 on the top. We can cancel those. So those two things can cancel. On the next line, I'll go ahead and fix that. So we'll have on top we'll have left x plus 2, and on bottom we'll have left negative 5 plus x. And if you want to, you can distribute this 5. You can take this negative out front. In fact, that's what I'm going to do. It's any way you want to do it is really fine. If you want to write this as negative 5 minus x, if you want to move this to the top, because you can move the negative to the top if you wanted to. You can make this negative x minus 2 if you wanted to. What I'm going to do is I'm just going to write this as negative on the outside. It doesn't really matter though. So negative x plus 2 over 5 plus x, or x plus 5. It'd probably be more common to see x plus 5 than 5 plus x. Okay, so that seemed strange, I'm sure. Just remember this principle for something like this. If you see something that's in the reverse order, you can pull out a negative to switch the order. That only works for negative, bear in mind. If they're a different order and they're plus, that means they're the same thing, because you can just switch it naturally. Alright. That concludes the examples for 7.1. I will see you in 7.2.